Okay, so hello everybody. Welcome to the seminar. Okay, so for a today class, I think I did mention in the normal class, right? Which is I'm going to revise the chapter 2 and 3, Form 5. Okay, you can see the screen here. We start from the differentiation. But later we see the time first. If possible, okay, we can add on the integration. Because 2 hours class, I'm not sure is it enough time or not. Okay, we try. Okay, we try. Okay, let's see here first. So for differentiation, right, you have a lot of things to recall back, okay? Since last time we spent about like couple of weeks, right, to finish everything here. So then, yeah, the first thing I have to recall back is this one. Limit. Okay. So I think you should recognize this thing here, which is something like this, right? Lim. Okay, see a lim here. X to a number. Okay. And let's say beside here is the equation. Yeah, for the limb. So basically, for this part here, I did mention in the class before, which is like, actually this A, right? Just have to sub in only. This A here, you have to sub in only. So similar like normal substitution, okay? Similar to the normal substitution, you have to sub this into the X. Yeah, okay. Similar to this one. Okay, so this is the first part here, okay, limit. Then I continue. There is a type of question, right, which is you have to like determine whether the function has limit or not. Yeah, there's one question here, this. Later we do. They will ask you, is limit exceeds or not? Yeah, there is a tough question like this. So don't worry, this one we do later, okay? This one I will show you in the question later, okay? So this is the first part here, limit. Okay, next one, which is the long step. Yeah. First principle. Remember the long step, right? To find the dy over dx, the long step here. Okay, so this part here will be the first principle. We have about 4 different steps, okay, to go through, okay? The first step here, you have to replace the x and y, become these two. Yes. Okay, the delta. Yes, long time no see. So the step 2, you have to go for elimination. Okay, the third step here will be you have to divide the whole thing by the delta x. Okay, and one more. Yeah, need to use the limit to sub the 0 into the x. Okay, this one don't worry. Later we do one question also for the first principle. Okay, so next one. After you learn the long step, right? This one so-called a long step. Long step to do the differentiation. The long step to differentiate. Yes, we have the shorter step, of course. Okay, we have the shorter step here, which is the formula. So this part here will be the differentiation. Okay, so the first one, type subtle. Yeah. Okay, type 1 here, which is, okay, this formula, dy over dx. I think you remember the formula, right? Should be remember the formula. Should be, I think. The power times to the front and then minus 1. Hey, the power times to the front minus 1. Okay, first type. Okay, second type will be a bracket. Yes, bracket with the power. Yeah, bracket with the power. So of course for the power here, right? This power here, a is not equals to 1, of course. Not equals to 1 or 2. Because power 1, right, you can open the bracket straight away. And power 2, you're able to expand also. So which means the power 3, 4, or even like negative power, then you have to go for the type 2 differentiation here. So here is the formula. dy over dx equals to, okay, same thing. You have to do 2 times. Start from the power outside here, outside bracket here, same thing, times to the front minus 1. Okay, you can see color, right? So it gets something like this. Okay, the n times to the front. And the n need to minus 1. Okay, first time. Then second time here, the inside here, yep, you have to go for differentiation again and sub it into this bracket. Yes. Ta-dang. This is the second type. Yeah, yeah. Okay, okay. Still okay, still okay. Okay, two more type. The third, the third type, right, will be when you have the an equation with these two, okay, times together, of course, and then they have unknown x, both. They have unknown x. But what I mean by unknown x is like this, because just now we know that for bracket, if power 1 or 2, it can expand, right? So what I mean is like now for the third type here, the bracket that cannot expand. This one cannot expand. These two here, double expand. Example like this. Yes, cannot expand this one because of the power 3, right, for the bracket. Okay, so this part here, you will have the formula. Copy, left, okay, then differentiation, right? Okay, and plus, now terbalik, copy, right? Differentiation left. So how determine the left and right, right? Look at the example here. It's x squared times the bracket, correct? So this is the left. This is the right. Yeah, that is the way, though. Okay, the third type here. Okay, one more. One more to go. One more to go. Okay, the last type. Just now we have times, right? Correct? Can I expand like this? Times. And one more we have divide. One more we have divide. Yes, there's one more here. We have the divide. So example looks like this. Sure. Yes, divide. Both also got x, or up and down also got x. And somehow, even though you bring up, right, you still gonna expand. Yes. So this will be using the formula of, yeah, the formula here bigger a bit. So copy bottom first. And then differentiation top. Continue minus the other way, copy top, differentiation bottom. Okay, nice. And the last one, the whole thing here divided by bottom square. So yeah, there's a long formula. So same thing here. How to determine the top and bottom, right? Also look at the fractional. So fraction here, this is a top law, the one on top, right? On top of the fraction. And this is the bottom law. Ta-da! So yeah, four different way of differentiation. Depends on which type of equation you have, okay? So you have to pray that your equation given, right, is either type 1 or type 2. Will be easier for you. Because type 3 and type 4, right? Yeah, same thing, but just working longer, of course. Okay, can. So yeah, this is the third thing, differentiation. Four different type here. Okay, now the fourth. Okay, right on top here. Okay, the fourth thing. The fourth part here will be about the tangent and normal. Tangent normal. So let's see the graph first, okay? Graph R. Tangent normal, these two, right? Okay, actually is a straight line. Okay, so the relation between these two straight line would be 90 degree. It's not a normal straight line, okay? It's a 90-degree form, okay? So the graph looks like this. So let's say you have a curve. Tangent touches one point. This is tangent. Touches one point here. So for normal will be touches the same point and it is 90 degree, which is perpendicular to the tangent. So the normal line will be touches the same point, okay? And it is perpendicular 90 degree to the tangent. So this is normal. Yes. So from here, the only thing you have to remember is the gradient. Yeah, the thing you have to careful is the gradient. The rest, just as the same thing. Just the gradient you have to careful. So for the perpendicular, the 90 degree here, right? Yeah. You should have a formula which is m1 times m2 equals to -1, which means the both gradients times together equals to -1. So of course, if you apply in the tangent normal, right, it will become tangent gradient, I put MT, times normal gradient, I put NN, equals to -1. Yeah, this part here. Okay, and one more last thing, also about the gradient. For tangent gradient here, yeah. This one, yeah. Tangent gradient here will be exactly same as your dy over dx. Yes, meaning that for a curve here, right? For a curve here, when you're doing the differentiation, you get dy dx, right? So that dy dx will be stands for the tangent gradient. Yes, but of course, tangent for this curve, right, actually got a lot, correct? It can be on this point, the tangent. It can be on the other line, let's say here. Or maybe it can be a different point, like let's say here. You can see a difference, okay? Can be a different tangent, right? So how do you find the gradient of tangent for that specific line here will be, you have to sublog. You have to sub the x to get the dy over dx for that tangent. Yeah, you have to look at your tangent is on what point. Ah, because different, you can see a line, right? This tangent, this tangent, and this tangent, you can see the gradient is totally different. So it depends on the point. Mm. Okay, so this one I have to be careful for the gradient. Yeah, because the gradient a bit confusing. Okay, still good. Okay, one more. Yeah, yeah. Maximum, minimum. Yeah, one more last one. This part here actually continuing from the tangent, okay? Because for maximum, minimum, right, actually also referring to the tangent, which is something like this. I draw a curve here. So let's say this is the minimum point now, okay? And you know that for the tangent, it passes through the minimum point, the tangent, somewhere around here, correct? And this line, you can see is totally straight, like the horizontal line, like the axis, totally straight. So for this gradient, it must be 0. This gradient, tangent gradient, or just like I say that this is also dy dx, right? Equal to 0. Yep. So this is your maximum, minimum, the formula. The differentiation dy dx must be equal to 0. Yes, because of the tangent line. The tangent line is totally straight, no gradient. So aga, okay, for these 5 parts here should be okay. We know that we have last 2 parts, right? We have the rate of change and small change. That 2 parts I'm not going to today. Okay, today I just focusing on these 5 things on it. Yeah. Yeah, just these 5 things for today. Good. Not feeling too good. Ding, ding, ding. Wow, a lot of things. Mm. So far, is there any question first? Still okay. Okay. So now we're going to, yeah, go for the exercise. This one, the one you have to discuss today. 10, 12, 14, 18, 20, 27, 46. Ding, 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 ding. Okay. If you manage to finish everything here, then we can go for the integration. Yeah. Okay, let's start from number 10. Number 10. 6, 7, 8, 9, 10 here. This one. This one is 3 marks plus 1 mark, total 4. Wait, 3 marks are for the A. So each question 1 mark. So let's see number 10. Diagram shows part of the function graph y equals to fx. Because of fx, these two. Don't know why the graph looks like this. Okay, so for question A here, based on the graph, you have to find f0. This is the x, right? Which means when x equal to 0, yeah, you should be able to find a point. if x equals 0, you have 2 points, right? But there's 1 point here missing, actually. There's 1 point here. There's also 1 point here. But the thing is like, yeah, this point not given to you. No equation given to you. We are unable to find the point actually. So the answer just 5. Yeah, done. 1 mark. Next, limit x to -1. So as I mentioned just now, for the limit, x -1 here, have to sub only. Have to sub only. So this time, x equals to -1. So you can look at the graph there. X equals to -1 is somewhere around here. So go to the graph here. After you sub in, you should get the answer is 2. Yeah, the answer is just 2. Done. Okay, still okay, right? So I think you can find the last one for me. Limit x to 5. This one need to sub also. Yeah, look at the graph. Should be okay for this. X to 5. Here, but still, I still feel curious. What a graph like this? So the answer is 4. Okay. 1, 2, 3. 3 marks done. Okay, next one. Here is the question that I asked just now when we start the just now the beginning there. You have to state whether the limit x to 0 exists or not. Yeah, so this is the part you have to know how to determine you have the limit or not. Okay, so first thing, x to 0. The 0 is x, right? Okay, so look at graph here. How do you know that whether you have the limit of x to 0 or not? Very simple. X to 0 is over here. On the graph, you can see that. Also over here. Okay, so now, because this graph has 2 different parts, right? This part, if from the left side of the graph, right, this part here, you go all the way until the point, okay, and then do the same thing from the right side. Go to the point also. Not sure understand not. Okay, I repeat here. From the left side of the graph, go all the way towards the point. Okay. And the right side of the graph is over here, right? The right side. Also go all the way to the point. Then you can tell me, are these 2 points same or different? You get the idea? Maybe the graph looks like too weird. From the left, go to the point. From the right, go to the same point. Okay. You should be able to see that these 2 numbers are different, right? Maybe I give you a simple example to understand, because this graph, I don't know why it's so weird. So let's say like this. This is a graph. Example, okay? So when x equal to 0, this is the point, right? So same thing, from the left side of the graph, go towards the point, go all the way here. And then from the right side of the graph, also go towards the point here. So now I can see, for this example, left side, right side, go towards the point, Same number, right? This point, same number, right? So yes, which means that this graph, it has the limit because they go towards the same point. Yeah, that's the way to determine. So that's why for this graph, don't have, because left side, right side, go towards the point is a different number. Okay, understand, but only 1 mark, okay? So this answer is no, lor, tak ada. Hey, hey. So number 10, done. Hey, hey. Still okay, still okay. Next one, go to number 12. Okay, can I? Okay, let's go. Number 12. Should able to understand. Quick, 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 quick. Okay, this part. Why the space so little one? Okay, the number 12, you have to derive the gx using the first principle. Yeah, so this is the part here. You have to go through the first principle, the 4 steps just now. Gx equals to 1 over x squared. Okay, so I make it easier for you to see, okay? I change the gx to the y first. So which means you get about y equals to 1 over x squared. So as you know, just now the first principle, I say it's a long method, right? It's a long step to find the dy or dx. So of course we have the shorter way. So if we're gonna go for the shorter way, we can check the final answer later. Yeah, we can check first. I do it over here. Y equals to 1 over x squared. We now go for the shorter way. The x squared need to bring it up here. Okay, and now we can start the differentiation. This one should be using the first type here. The power of x, -2, times it to the front, -1. So -2, x to the power of -3. So then -2. Yeah, the x power negative bring back the bottom. So you will get this answer later. Final answer. Yeah, this is your final answer later. Using the shorter way. But now the longer way here will be, yes, the first step. The both x and y. You have to replace to these two. That's your first step here. Okay, then continue. We open the bracket. Okay, the bottom one. Okay, so x to the power of 2, no issue. The next one is x times delta x times 2, right? When they expand it, x times delta x times 2. So you get this. These two x, as I mentioned before, these two x cannot become square. Cannot. These two x, you have to write it separately. Ding, ding. Okay, and the last one is delta x to the power of 2. Yes. Also cannot become what? Delta square x square double A. you have to separate also. So you get these three after you expand the bracket. Okay, so step one done already. Step two will be going for the elimination. The step two now we go for elimination. So be elimination using the question. And just now, you're working after expand. 2 minus 1. Yes. So for the left side here, you minus the y gone already. No? You left only delta y. But then for the right side, the right side cannot minus all. These whole fraction minus 1 over x squared. Don't cut the x squared. Cannot cut. Okay. So when this one minus cannot cut, right? So no choice. Just copy only. Yep. Just copy only. So then this one need to simplify. Need to simplify. So yeah, these two fraction. How do we minus for these two fraction will be, yeah, fraction. Need to make it same denominator. Hey, okay, so yeah. This whole thing need to times x squared, the top here also. The other fraction, yes, need to times, yeah, and also on top also. Hee hee. Okay, let's go. Yeah. Okay, so bottom expand, shoot, shoot, shoot. X power 4 plus 2x cube delta x. And the last one plus x square delta x square. Oh yeah, not feeling too good. Okay, the top there also 1 times x square minus the 1 here you have to type by everything here. So wait. So right again. This is delta x. Tâng, 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 tâng. It seems like getting okay lah. We have the x power 3 lah. If you compare with the final answer. Okay, continue. Draw. So x squared minus x squared, no more. So the negative just expand into the bracket. Good. And the bottom, nothing lah. Okay. So second step, just like this. Hey, hey. Now I have to go for the third step. Hey, yeah. Okay. I think I need more space. Sure. Okay. Okay. The next step, I need to divide the whole thing by delta x. Okay. The left side need to divide also. Mhm. The right side when you divide, right? Because the divide, as you understand that it can become times, correct? The divide can become times. Yeah, that's why for the 1 over delta x here, you can straight away times it to the bottom part here. Can times it into the bottom part here. But this one can simplify when we times the 1 over delta x. So we just leave it outside the bracket. The delta x will leave it outside here. Can see? So for the top there, right? For the top there, these two also got delta x, right? We can factorize out the delta x. Good job. Yes, we can cut. Choo, choo. Nice. Tung, 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 tung. Still okay. Still okay. Mhm. Okay, Okay, so left about the top there, negative 2x minus delta x. The bottom here, 1, 2, 3. Okay, so anything here we can simplify. The up and down cut already. Okay, okay, no, no, no. Now, last step. Finally. But it seems like we cannot get the answer though. It's okay, we continue. Okay, the last step, lor, which is the go for the limit. We go for the limit now. Okay, yeah, right. Right here first. Ta-da! So limit the delta x becomes 0, which means, yeah, you have to sub in, no? The 0 here have to sub into delta x, delta x. Okay, so on top there, bottom here. But this working can skip since like sub in the 0, right? So the 0, 0, 0 all done. So you get negative 2x over x4. Finally, x and x4 can cut. Chop, chop, 3. Yay! So, yeah, that is your dy over dx. So number 12, yeah, just like this. I know it's a long step because of the simplified there. It's a long step here. That's why first principle, okay lah, I think. Yeah, this one I'll wait for you first. Next one go to number 14. Okay. First principle. Mhm. Tăng, 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 tăng. Not feeling too good, I know. Not feeling too good. Quick, 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 quick. Go, 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 go. So anyone haven't done yet? This is what. Okay, done. Let's go to number 14. So you have done the limit. We have done the first principle. The next one, yeah, number 14 should be the tangent normal. Let's go, let's go. Here. Oh, this is not tangent normal first. Number 14, number 14. The curve has stationary point at negative 1q. Find the value of P and Q. So first thing here, stationary point, right? Same as your maximum minimum point. Same. Wow. Wow. Stationary point, same as your maximum minimum point. Same. Same. So which means that we have one more hidden info, which is, because this one I did explain, maximum minimum point, the tangent is totally straight, right? Totally straight. That's why the dy over dx, the gradient, it must be equal to 0. Yeah, this is a hidden info, stationary point, maximum, minimum, okay? So then, yeah, we can now use the info already. So follow the info here, dy over dx, need to do the differentiation now. But of course, don't use the first principle. We go for the faster one. Px4 plus 3x. Okay, so from here, do the differentiation, the faster one, the faster one. So the power times to the front, minus 1. This one same also. Okay. 4px power 3 plus 3. That's your dy over dx. Okay, good. So now we can sub in the dy over dx. 0. And the dy over dx, right, is on the point negative 1q, correct? It's on this point, the dy over dx. So you have to sub in the negative 1 also. Okay, both. So sub in dy over dx. The x is negative 1. Okay, I think we can now find, yeah, we can find Q already. Open the bracket, bring everything over, can find Q already. So this guy can continue. Open the bracket, bring everything over. It's not 4 marks. I think we rather do the question, right? This one, compared to the first principle. Okay, done. Negative 4p plus 3. 3 over 4. This is the p value. Okay, first part done. And last part, the q value here will be Is there any other info? I think no more, right? Just now we already used the dy over dx. Okay, so to find the q value, this is the point on the curve. Yes, so we can sub it in. This point, we can sub it in. -1 is x, q is a y. So sub in together with the p value. Then you can find the answer already. -1 is x, the q is y, p is 3/4. Yeah, we can expand, find the value of q. Okay, so this one you can straight away press the calculator. 3/4 times -1 power 4 plus 3 times -1. Okay. -9/4. Finish. This is the 14. Some 4 marks is better, right? Just now the first principle only 3 marks. Eh? Okay, 14 finish. Next one, 18. Okay, done. Let's go. 18. Yes, this one will be the tangent normal. This one only 3 marks. Okay. The normal to the curve at point A. Okay, normal to the curve at point A. Okay, I draw the graph for this one first. Normal to the curve. So you have a curve here. Tangent touch one point, right? So now the normal will be touching the same point and it is 90 degrees to the tangent. So normal will be touches the same point and is 90 degrees to tangent. So now this point is point A. That's the meaning for this one. Normal to the curve at point A. Okay, I copy the equation here first. This is y equals to 2x squared minus 7x. Okay, the first part of the sentence, continue. This normal to the curve, right? Normal to the curve here is parallel to the straight line. Yeah. So repeat here. This normal to the curve, this straight line is parallel to another straight line, -x plus 14. So another straight line, sure. These two are parallel. Yeah, I got okay with the graph here. So last one is find the equation of normal to the curve. At the point A. So yes, you have to find this one. Okay, first thing. So first thing here, this straight line, of course, straight line formula, y equals to mx plus c, right? But you have to careful on the gradient. Y equals to mx plus c. So this is a formula for your straight line. Okay, so then later we need to find the gradient first and start a point to find the c. Yeah, two parts here. So now you have to careful on the gradient. Okay, gradient part here, we now know that we need to find the normal straight line gradient. Okay, And normal and tangent both, okay, perpendicular, 90 degree. So their gradient times together must be -1. Correct, correct, correct. Ah, but then this question, look at the graph, got one more way. Yeah, got one more way. Instead of going for the uh, perpendicular formula, one more way is these two lines, yes, they are parallel. So they are sharing the same gradient. Yeah, they share the same gradient. This gradient, same. So, yep, this is the one of the way. The second way is the parallel. So, of course, parallel is more faster, right? For this question here. So, there is y law. The straight line -x plus 14. Yep, you should know the gradient is -1. And this will be the gradient of normal. So far, okay. But normally we go for the 90 degree. Normally we go for the perpendicular. But now this question here very good. You can get the gradient straight away. So the first part, okay, this one done. Hey, yeah, the second one, the C, you have to sub 1 point. This part here, you have to sub point. So the whole straight line here, there is only 1 point. A, yes. So need to find the point A, use the point A to sub in to get a C. Yeah, the whole straight line only got 1 point, point A. Need to find a point A, okay? Haha. Okay, so let's go. So the point A, tangent also on the line, right? Correct. So for the tangent gradient, as I mentioned just now, this is your dy over dx. Correct. Okay. So we have the normal gradient. We are able to get back the tangent gradient by substitute the -1. Yeah, here. Shoo. Yes, we can sub here. And bring over to get mt. Mt will be stands for dy over dx. Not feeling too good. Okay, so we sub in first. Okay, we sub in first. Mt times. So mt get 1. Dy dx will be also 1. Okay, because they're both the same, right? Yeah, so here you go. Now we have the tangent gradient 1, the dy dx. Okay, so from the curve here, you're able to do the differentiation also. Then you got 2 dy dx. I repeat here, the curve here, you also can do the differentiation, right? You can get the second dy dx. So the first dy dx, 1. The second dy dx here, later you can equal. Later you can equal. From there you can find, you can get back the point already. Kaboom. Okay, let's hey, go to the curve. Okay, do the differentiation. The power also times to the front -1. Power to the front -1. Yep. So these two, dy over dx, dy over dx, same. So the 4x minus 7 and 1 can equal. Ta-da! Yeah, so yeah, we can now find the x. The x answer, it will be belongs to the point A. So 1 plus 7 is 8. 8 divided by 4 is a 2. So point A, the x is 2. Okay, then continue. After you find the 2 already, can now sub it in to the curve here and find the y. Yeah, so you have your point A. Two times 2 square minus 7 times 2. 2 times 2 square minus 7 times 2. Negative 6. Okay, lor. So now, yeah, this is the point A, lor. Oh, yeah. Feeling okay. So now we can sub the point A into the formula to find the C. Okay. Y equals to M X plus C. Negative 6 plus 2 is negative 4. Okay, so done. Gradient negative 1, the C you get negative 4. Okay, done. Okay, 18, finish. Next one is 20. We have 3 more. Okay. Are you okay? No. 3 marks. The 3 marks okay actually. Actually, the working just the black color one. The red color and blue you can just skip because the blue is the graph, the red color is a formula. Yeah. And some of the black color working can skip also. So should be okay. Okay, so 18, all done. Next one is 20. Okay, done. Let's go. 20. Oh, 20, 20. The straight line is normal to the curve at point P. Okay, so again, I will draw the graph here. So the straight line 3y plus x plus k is normal to the curve. Curve. Wait, yeah. Wait. So this is a tangent. Okay, touches one point. So the normal to the curve at point P will be passed through here and is 90 degrees to the tangent. So this point actually is point P, okay? This point. So similar to just now. So we have the normal equation already. 3y plus x plus k. And we also have the curve x squared minus 3x plus 1. Okay, good. Any other number here? Okay, no more already. So we can now start the first one. Find the value of k. Where's k? Okay, k is over here. So to find a k, right? K is the equation is the normal, correct? This is the normal equation here. To find a k, because k is not the gradient. So to find a k here, right, we need to sub in the x and y. Yeah, so which means that we need 1 point. The only 1 point we have, point P. Need to find point P, then we can sub in here x, y to find a k. Need to find a point P first. Point P, yeah. So this way of point P actually same as just now number 18 or same or. We start from the curve, also do the differentiation, get the dy dx. Then later on, the normal equation, we also can get the gradient. But of course, you know lah, this gradient is not the dy dx. Tangent is dy dx. So after you find the normal gradient, need to sub into the 90-degree formula to get back the tangent gradient, and that gradient will be dy dx. So later you got 2 dy dx. Yes. Okay, slowly. We start from the curve first. This curve, we do the differentiation first. Okay, so do the differentiation. The power times to the front minus 1. Next one, same. Right? The power times to the front minus 1. Why got so many x1? Oh, sorry. This is power 1. Nothing. Haha. So last one number, no x, right? This one differentiation, you get 0. 0. 2x minus 3. That is the dy dx. Okay, that's the dy dx. So this one we hold on first. Hold on first. So go to the normal here. Find the gradient. Okay, and the gradient, you can get back the tangent by using the perpendicular formula. Okay, and the tangent gradient will be equals to the dy over dx. Okay, slowly. Let's get the gradient first. Normal gradient. 3y plus x plus k equals 0. So to find the gradient of normal, bring everything now. Need to find y equal to mx plus c. Okay, the 3 also bring over. Divide. So yep, that is your gradient of normal. Here. Okay, now we can sub in to the perpendicular formula. Mt times mn equals to -1. So sub it in here. Shoo. And then bring over. Mt times -1/3 equals to -1. So bring over -1 divided by -1/3. 3. Yep. So this is your mt. This is also your dy over dx. Ta-da! Okay, finally, dy dx, same. Okay, equal. 2x minus 3 equals to 3. So from here, we can continue. From here, we can find the x, right? We can find the x. The x can sub in back to the curve to find the y, and you have your point P. Yeah. From here, you find the x, right? The x is belongs to point P, yeah? So for the x, sub in to the curve, find the y. You have your point P, and the point P sub into the normal equation. Then you can get the k. Yeah. So this part can continue. Find the x, sub into the curve, find the y, and the xy later, sub into the normal equation. Later question B is what? Okay. Okay, almost done, right? 3 plus 3, 6. 6 divided by 2 is 3. Sub into the curve. X squared minus 3x plus 1. 3 squared, 9. 9 minus 9 is 0. So it's 1, no? This is point P. Yes, and then use a point P. Point P, right? Sub into the normal equation to find the K. Okay, so 3y plus x plus k equal to 0. 3 plus 3, 6. Ding! Okay, first part done. Yay. So I think after find the part A, you have your point P, you have the gradient of normal, tangent, you got everything. So the part B, very, very easy. Equation of tangent to the curve at point P. So yeah, now you're getting this line. Okay, so just now again, we already have the normal gradient, negative 1 over 3. And we already sub in, right, to the perpendicular. We got the tangent gradient, 3. And some more, we have point P also, 3, 1. Okay, lor. So actually we got everything. So follow the straight line, y equals to mx plus c. Gradient, done. And then to find the c, need to sub point, right? So the only one point on the line is point P. 3, 1. Use the point P to find the c. Let's go, let's go. Y equals to mx plus c. 1 minus 9 is negative 8. So, yeah. 20, finish. Next one, we go for 27. We have 2 more. Dun, 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 dun. Okay, okay. Okay, done, 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 done. Anyone haven't done yet? So 4 marks, okay lah. The part B, the working shorter. Okay, good, done. Let's go. 227, last 2. Later we can go for integration. 27. 27 is Um, apa ini? Roller coaster. Hmm. Oh, this one 5 marks eh. Ooh, okay, very nice. So you can see the diagram shows the roller coaster track. You can see here. Phew, woohoo. Mhm. Okay, so bottom here, the curved part of the track represented by this equation with point P as the origin. Okay, until here first, the curved part is over here, right? And it says that point P is the origin, so which means point P here, not true. Yeah, not straight. Not true. B chat. This is your X and Y. Oh, no wonder the picture already saying it. No wonder, it's okay. Okay. Okay, again, point P is the origin, so your X and Y axis must be there. No? Okay, can see. Okay, so the question asking for, find the shortest vertical distance from the track to ground level. Shortest vertical distance. So vertical is, you know the vertical, and the shortest, right? Somewhere around here, correct? Here to the ground level. I need to find this distance. Okay, so I think this question okay. Just seems like a bit scary because of the picture here. So if you want to make it the shortest, right? The shortest, these coordinate from the graph, right? You should know what point is this. This point. It must be the closest to the ground level. Yeah, closest to the ground level. This point, it must be the minimum, the lowest point of the curve, the lowest point. The lowest point will be closest to the ground level. No? This is a minimum point. Yeah. So now you have to get the minimum point. Okay, you get minimum point. And then from there, right, to calculate the distance, we need the y coordinate for the minimum point. Yeah, we need the y coordinate. So let's get the minimum point first. So minimum point, maximum point, everything same. The working I write. Okay, I write here first. Minimum, maximum. Yes, the dy dx, the tangent, gradient must be 0. This one 5 marks. Okay, so the curve is 1/16 x power 3 minus 3/8 x squared. Correct? So now we go for the differentiation. We do the differentiation. The power times to the front minus 1. Same thing for the next one. Power times to the front minus 1. But what is on 5 marks? Seems a lot. Not really worth the 5 marks though. If the working actually lesser. Okay, so okay, continue. So continue, sub in the 0 to the dy dx. We can find the x coordinate already for your minimum point. Hey. So sub in the 0 to the dy dx. Okay, and then need to simplify first before we press the calculator. Yeah, because the fraction. and times the whole thing by 16. Then you can cut off the fraction. 3 over 4 times 16 will be at about 12. Okay, so yeah, no more fraction. We can now press the calculator to factorize it. Good job. Good job. A is 3, B is negative 12, C is 0. Okay. Dun, 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 dun. 0 and fall. So actually got two minimum point. Sorry. Yeah, two minimum point. But the one that we need to use is 4, right? It's not 0. Yeah, we have to use 4. You can see the place here because this is your x and y axis. So this this x coordinate, yeah, must be 4. So use a 4 to find a y. 5 marks. Okay, continue. So use a 4, in back to the curve, find the y. Okay. E, e 1 over 16 times 4 to the power of 3 minus 3 over 8 times 4 squared. Ta-da! Negative dual. So your minimum point is 4 negative dual. So here is 4, here is negative dual. Doesn't seem like 2 also. But we have to follow, okay? The picture not really accurate. Okay, good. So I think, yeah, we can now find the answer. So to find the distance of this part here, total is 5, right? The negative 2, as you know, is belongs to this side. Negative 2 is belongs to this. So the remaining part there, yeah, it seems like, yeah, doesn't make sense, but you have to follow lah. 5 minus 2, 3 meter. Like this 5 marks, eh? Wow. Dun, 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 dun. 27 done. Okay, before you first, last one I go for 46. Go. Still okay, oh. Mhm. Okay. Okay, done. Let's go to 46. One more. 46. 46 is what idea? Okay. Okay, let's go. 46. Quite far away. Phew. 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 Okay, here. Okay, this one no marks. Okay, it's okay. Okay, 46 here. Again, below shows part of the curve. y equals to x bracket x plus 2 to the power of 3. Yeah, the graph looks like this. Okay, so A, find an expression of dy dx. Basically, just have to differentiate only lah. Need to do the differentiation only to find the A answer. Okay, the working I write here. You can write bottom. Bottom got more space for you. Yeah. So to do the differentiation, right, this time you can see that the bracket double expand. Cannot. So this one need to go for the third type of the differentiation, the copy left right method. I write here first O, copy left, differentiation right, plus copy right, differentiation left. Yep, just now this method. So your left and right side, these two, x and x plus 2. Okay, so let's go. Copy left, right, you should be okay lah. Just copy only. So the differentiation left and right. Okay, this one I'll write it separately. You can put everything one shot if you want. So I start from the differentiation left is x, right? So the power times to the front minus 1. Okay, so this is the differentiation left. Okay, now go for the differentiation right. Right side is x plus 2 to the power of 3. Okay, so this one need to go for the second type here because of the power can expand. So power 3 times to the front minus 1. Okay, one more bracket. The inside here, yes, need to go for the differentiation also. This part, differentiation, and then put inside here. Phew. Dun, 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 dun. Okay, which part not sure, you let me know. So this is a differentiation right. So you can put now everything into the formula. dy over dx equals to, okay, copy left, differentiation right, plus copy right, differentiation left. So yes, we cannot stop here. We have to simplify. Let's go. The bracket power 2, power 3, I'll just keep it, okay? This power 2 and power 3, I'll just keep it. So we just expand the rest only. 3 times x, the power 2 at the back here, I just remain. And followed by this x plus 2 to the power 3. The 1 times anything same lah. So you get this one. Haven't done yet. Still have to continue simplify. Okay, now you can see these two sides, right? They can both can be divided by x plus 2 to the power of 2, correct? Both sides. Both can divided by x plus 2 to the power of 2. So you're going to factorize. Long time no see. Remember last time quite suffer, right? About this part here because of the simplified thingy. Okay, so for the left side, after you factorize, after you divide, so no more x plus 2 square. you left only 3x. Plus x plus 2 power 3. After you factorize, you divide by power 2, you left only one more. So, yep. Okay, finally, though. Plot together 3x plus x, done. That is your dy over dx. Dun, 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 dun. This is the first part. Seems like okay. Dun, 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 dun. Next one. Ooh, okay. Okay, good. Until here should be okay for you. Next one also quite okay actually. Okay, B, next one. Find the coordinate of two stationary points, P and Q. So just like we did the similar question, right? Stationary point got one hidden formula. Maximum, minimum. Yeah, stationary stands for maximum, minimum. So the dy over dx, 0. Okay. So yes, and now we already have the dy dx from the part A. Okay, so now we can sub in the 0 into the dy dx. So then later we can find the points ready. So it seems like if the part A get wrong answer, then part B, hey. You know. Okay, so dy dx equals 0. So sub it in, which means this whole thing equal to 0. X plus 2 square, 4x plus 2. X plus 2 square, 4x plus 2 equal to 0. Okay, from here, no need to expand. Please don't expand. If you expand it, right, later on, you still need to factorize, which means you're going back to the same bracket. Yeah. Okay, don't expand. If you expand it, right, you still have to factorize back to the same bracket. So actually, this bracket already like simplify for you. So from here, how do we find the coordinate, right? Just equal 0. Because as remember the general form, the bentuk arm, right? You have two bracket, correct? The general form, two bracket. So normally you press your character to find the answer. But last time, long time ago in form 4, you did one working actually, but you I think like slowly skip the working already. Like after you've pressed your calculator, you get the answer correct. And actually between here got one more step before the bracket, which is like this. If let's say 1, 2 the x, the 1 need to bring over, 2 also need to bring over, and then only you put inside the bracket. Yeah, remember? Long time ago, last year, when you start to learn the general form, there is a hidden step here actually, but we skip that because there is no marks. That's why for this part here, same also. This part here, these two brackets, same as the bracket here. So to find the x, right? Yes, the bracket both need to equal to 0, like what we are doing here. Okay, so then we can now find the x ready. Plus 2 bring over. This one bring the 2 and bring the 4. So, yep, -2 and -1 over 2. If you follow the graph here, you should know that -2 is belongs to point P. -1 over 2 belongs to point Q. Yeah. So then continue, haven't done yet. Need to sub in the x back to the curve to find the y. Only then your point complete. Sub the both x to find the y. Okay. This one I get 0. Yeah, 0. Next one, -1/2. Okay, -1/2 times -1/2 plus 2 and then to the power of 3. Yeah, I didn't press wrong, right? -27/16. Yeah, yeah, this is the point Q. Is it the answer correct? Yeah, really. Okay, so this is a part B. 2 stationary point. Yeah, I think I need more space for the question C. Okay, still can. Can go for the question C now. Okay, question C here. Subsequently, determine the nature of stationary point P. The nature is not the nature that you know, okay? The nature just meaning type. What type is the stationary point P? Yep. So to determine the type of the stationary point here, long time no see, you have to go for the double differentiation. Yes, d square y dx square. Hey. So you see that? Just now the dy dx, this answer, need to do the differentiation again. And this time because of the bracket again, right? And this one actually, if you want can expand, this one still can expand power 2. After expand, then 4x plus 2 times inside. Can also, but the step a bit longer. So we can go for the same method again. Copy left, right method. Okay, so let's do the differentiation again. Okay. So this is the left side. This is the right side. So copy left, right again, you should know that. So now you have to go for differentiation, left and right. Let's find these two first. Differentiation, left. Okay. So the power 2 times to the front minus 1. Don't forget the inside also. X plus 2 need to do the differentiation and put inside here. So this is your differentiation left. You can type the 2 inside. Now go for differentiation right. Power 1 here, so same thing times to the front minus 1. So you get about 4x0. The plus 2, no x, right? Becomes 0. Okay, lor. So now we can put the formula. dy over dx. Copy left. Differentiation right. Plus copy right. Differentiation left. Wow. Okay. We're supposed to do the simplifier, correct? Suppose, but because of we have to sub in the point P to determine the type of the point here. So we can just stop here, and then stop here. And now we can sub in the point P. Where's the point P already? Yeah? Negative 2, 0. Yeah, we can sub in the point P here. Mm. Of course, just sub the x. The y equals 0, no need. The answer is so weird. Sorry, it's d square y dx square. I write the wrong symbol. Yeah, so you can now find the answer. And then we can see which type is this. Dun, 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 dun. Negative 2 plus 2 squared times 4 plus 4 negative 2 plus 2 2 negative 2 plus 2. Hey, nice number, 0. Yeah. Okay, so now the type of the point, right, for the P will be like this all. You know that for maximum, the double differentiation, it will be a negative for maximum. Minimum will be the opposite. Yeah, so now if equal to 0, right? I think last time, yeah, I'm not sure. I mean, your first time see this type of answer or not. If the d square y dx square, which is the double differentiation, you get 0, this type of point, right, is inflection point. Yep, inflection point. The BM is the titik lengkung balas. You can look at the bottom answer here. This one. Titik lengkung balas. Inflection point. Mm-hmm. It's a bit a bit special, I know, this one for equal 0, a bit special. Okay, so actually for this point, right, there is a way to see, okay? You look at your graph here again. Okay, you already write the name, right? Okay, look at the graph here. You can refer to the tangent to know. So let's say for point Q, right? Yeah. Okay, why is it not moving? Okay. You can see the line, correct? So point Q here, this is your minimum point. Okay, minimum point you see, right? You see a tangent, it starts from the slope, which is going down, correct? The tangent, and then slowly turns going up. For minimum point. See that again? Starting going down, correct? And then slowly when the point change to the minimum point, it becomes straight. And then continue go up there. The point, you can see a line become going up. Yeah. So this is a minimum point. For maximum point will be opposite. Okay, I draw here. For maximum point, eh, okay. Can see right? Why is it not moving one? Okay, can see from here, slowly turn all the way to maximum point, become straight, and then slowly continue all the way here. Yeah, so which means the tangent this line, right? You will turn from, I mean, let's say from maximum point, you will turn from positive to 0 and then to negative for maximum. Minimum will be opposite. Minimum start from negative, turn to 0, and then turn to positive. But for point P, right? You see, point P, start from negative, slowly turn to 0 because of the point P there. And then, we don't know why it become negative again. You can see the line, correct? So you get the idea on this type of point here, inflection point. You can look at the tangent to know. The tangent, the gradient, no change. Negative, then turn to 0, and then turn to negative. Or maybe positive. Positive, turn to 0, and then continue positive. That is your inflection point. Okay, get the idea for this type of point here. Inflection point. Okay, still okay. When the double differentiation equals 0. Okay, good. Of course, you have to write the point out. That's why they ask you to determine the type. After you know what type is it, you have to write out the answer. Same as the rest. If you find that this is, let's say, negative, you have to write maximum point also. The name need to write out the name. Okay. Any other question? Type of stationary point. Okay, no. Yeah, we can go for one short integration, a short one. Okay, the short one. We flip to the page 21. There is an integration, but I think the time not really enough. We go for number 10 only. Yeah, number 10 only for integration. Just number 10. Let's see about one part here for integration. Number 10 only, number 10, just number 10 only. Okay, what's one? Here. Woohoo! A rocket. Because we did this chapter already, right? Correct? In the normal class. And you know that we did the area and volume already. Okay. So actually for this chapter, right, there is a possible type of question which is also finding area or volume, but they give you a picture. It's not a graph. This is a picture. Yeah, okay, let's see here. Diagram shows the nose cone of a rocket in a parabolic shape. Parabolic means is a quadratic, lor. This one. This one means is a quadratic, parabolic. So it's either set face or smiley face. Okay, the first part here. Okay, at the bottom. Given that the function of the parabolic shape is y equals to ax squared plus 5, and the base diameter of this nose cone is 3 meter, is inside picture here. So this is the part. Ta-da! A value. Okay, I write here first. Okay, first thing, because of this is the quadratic, right? And you can see the shape of the graph. It is a set face. You can see that. This is a set face. Shoo. Okay, set face, which means the A value, it will be a negative. But they're not asking for range. They're asking for value of A. Value. So you have to get the exact number, okay? So how do we find the A value here will be, because of this one, they give you the picture, correct? It's not a graph, right? No x-axis, no y-axis, right? We need to add on the both axes ourselves. Yeah, need to add on ourselves, okay? How to add on? We see the equation given to you. Okay, first thing you know, this is a set face. Next thing is this plus 5. This plus 5 is your y-intercept. Correct, right? Okay, so now when you add on the x and y-axis yourself, right, you add on already, you must make sure that the y-intercept in the correct place now, okay? The y-intercept, y-intercept is on the correct place. Example like this. Yeah, this is your y-intercept. If you put other way, right? Let's say you put here, yeah. Let's say I put here. Actually, this one can, no? Yeah? This one accept also positive, right? It can be 5 also. But you got one problem here. You only got the 5 as your info after you draw. No extra info. No extra info. You can't even use the 3 meter here. That's why the reason I put it in the middle here, because if I put in the middle, I will cut the whole graph exactly into half. Is it better? Because you can use the 3 meter. You can use a 3 meter. The 3 meter after half already, it become like 1.5. These two be 1.5. These two is 1.5. And this is negative 1.5. Is it you get more info, right? You get more info, right? Is it? You get more info, right? If you put in the middle. So really you can simply put the X and Y axis, but make sure after you put already, you have extra info. If you can't get extra info, you cannot find the value of A. Cannot sub in, right? You have no extra point already. So normally, there's only 3 different ways to put on it. It's either you put in the middle, cut in the half, or you put all the way to the left side, all the way to the right side. The other, I mean, the rest, like in the this place here, actually not recommend, because you can't get extra info. You put all the way to the left, to the right or in the middle. But because of it has the y-intercept, so for this question, you put on the left, tak boleh. Because the y-intercept is not 5, right? If you put here, the y-intercept here is 0, it's not 5. Yeah, so ding. Yes, okay. So yeah, that's the way. After we put in the middle, then we have extra number. Extra number, you can see extra. This point is 1.50. Yes, we can sub into the xy to find the a. $1.50. You can even choose the negative 1.5 lah. Same answer, same answer. Okay, so continue. Expand the bracket. 1.5 square. 9/4. So bring over the 5 and negative 5 divided by 9/4. Okay. Negative 20/9. So this is the A value. The answer here, okay? Yeah, correct. It's okay, right? On how to add on the X and Y axis. Okay, good. Let's go for the last one. B. Getting the volume of the nose cone. I write again the equation or after you find the A value. I write again here. A is negative 20/9. Yeah. Okay, this is the equation of the set face. Okay, so to find the volume of the nose cone, right? I recall back the formula first. We have two formula. The first one is the graph using x-axis to rotate, which means rotate up and down. For dx. For dy, which means the graph using y-axis to rotate. So look at the graph here. This set face. To get this picture right, it looks like the rocket shape here. Which axis do you think it is using to rotate? Rotate up, down to get this shape here, or rotate left, right to get this shape? It's okay. You should get, yeah, correct. It should be rotating left, right to get this rocket shape. Left, right. So using the dy formula. It's surround the y-axis, right, to rotate. So using the dy formula. So continue. So now, this x squared is your graph, lor. Okay, later need to find the x squared equal. Okay, and now these two y, right, will be, look at the graph, it start from this y all the way to here, right? When you rotate, it start from the y equal to 0 all the way to 5. Yep. So let's go complete everything. Okay, let's find the graph equation first. So now the graph here, we have to find x squared equal because of the formula. So I bring the negative 20 over 9x squared here. The y I bring over, followed by 9 and followed by 20. Blah, blah, okay. 45 divided 20 is 9 over 4. So that's your x squared. 45 divided 20, 9y divided 20. So you get the x squared. So yes, we can now sub in everything into the formula. Okay, 0.5 with the graph x squared. Dun, dun, dun. Okay lah, so now let's continue. Finish up everything. Quick, quick, quick. Okay, we have to go for integration now. The power plus 1 divide the new power. Yes. This one need to add on the y0. Okay, we can plus 1 divide the new power plus 1 divide the new power. Yes. Wow. 9 over 4 divide 1, same. 9 over 20 divide by 2. Oh, yeah. 9 over 20 divide by 2. Okay. Okay lah, we can now sub the 5 and 0. The 5 first are the big one. Minus. Oh yeah. Nine over 40 times 5 square. Yeah, the one is sub 0 equals 0. So 45 over, 45 over 4 minus 45 over 8. Yeah. Same answer one. Is it? Yeah, it's a weird answer. Hey, they could put a unit. Okay. If you want to put a unit, can also. Meter power 3. Yeah, if you want to add on the unit. Duh, 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 duh. But this one just add on for you, okay? Because we did this chapter already, but just that the question type, we never see this type before. Yeah, that's why we go through one question like this. So the things you have to know for this question actually just how do you add on the x and y axis? Yes, correct. That part only. The rest everything same. After you know how to add on the x and y axis, you're able to get back the equation and then use the equation to find your area or the volume. Okay, can na? Okay, wait for your first go, go. Dun, 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 dun. Quick draw, quick draw. Okay, almost there. So basically today will be until here first. Okay. So what else? Yeah, of course, the chapter 2 here, we have no time to go through every single type. We haven't go through we didn't go through the rate of change and small change. Yeah, all the tangent normal and the maximum minimum, you should be okay already on how to find the answer. Okay, so hopefully the seminar today will be a little bit helpful for you. A bit, maybe a bit. Okay, so I think yes, that's all for this seminar. Thank you for coming, and maybe I will see you in the next one. Okay, that's all. See you. Bye bye.